Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to have the input as well as concurrence regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat. And from there onwards, we have been starting the new and the important topic within the control system, and that had been the second order time response analysis. As far as the yesterday's class is being concerned, we were taking few number of questions which had been based on the concept of first order system. What does that mean by the first order system? That means the system had a transfer function, and the transfer function had only and only one number of closed loop pole. And as per the gate is being concerned, in gate the second order system had been more important than the first order system. So I thought to spend good amount of time over the second order system in compare with the first order system. That is why only one session has been planned for the first order system, and from today onwards we would take around 2 to 3 number of sessions over the second order system alone. The complete series which had been running for the control system is being CTQ, concept through the question, but is still deliberately the today's video had been planned to discuss a bit about the theoretical understanding of the second order system. We'll try to understand what does it mean by the rise time, what does it mean by the settling time, what does it mean by the delay time, similarly what does it mean by the peak time, what does it mean by the steady state, what had been the spatial structure of the second order system, what does it mean by the zeta, how the damping ratio used to affect the output response. If the zeta goes towards a positive value, have the only and only real part, positive value had the real as well as imaginary part, how it's going to affect your complete response, because most of the time the problem do get framed in vicinity to this many concepts. Could you understand what exactly I wanted to communicate over here? So I would say the student who have been following me, they should also start writing few of the important points. So the agenda behind today's video had been very precise and clear. We have been talking about the second order system. My dear friend, at least the order of the system had been clear to all of us. Probably 3 days back, I was discussing the difference between the type of the system as well as the order of the system. What does that mean by the order of the system? The number of poles a certain system carries. Yes. So obviously in case of second order system, the 2 number of poles the system is going to carry. Keeping aside each and everything, let me start with the standard second order transfer function. Standard second order transfer function. If the transfer function is being referred by T of S, in a standard form the second order transfer function is being represented as k omega n square divided by of s square 2 zeta omega ns plus of omega n square, omega of n square. Could you really understood what had been happening over there? Obviously. In the same sequence, what had been happening over there, my dear friend, just understand in this way. Transfer function has to be unitless quantity, at least when we have been dealing the same I can say same physical quantity towards output side as well as input side. So in that case, the unit towards numerator as well as denominator has to be very same. That you can see that had been happening. See, omega n square, the omega is nothing but the radial frequency. What would be the unit of radial frequency? Is going to be radian per second. So the unit of omega n had been radian per second, and if it had been raised to the power of 2, is going to be radian per second has been raised to the power of 2. If this has been radian per second to the power of 2, no, the each and individual component which is going to get added with the omega n square should also have the same unit. Obviously it had been s can be replaced with the j of omega, and if you will raise the power of 2 again, it had got the unit of omega, and that has been radian per second has been raised to the power of 2. Here omega n, again it had been radian per second, unit of s is been again radian per second. So obviously the zeta is going to be a unitless quantity, which we would be calling as a damping ratio in future. And similarly, if you will talk about the numerator part of this transfer function, you yourself would be able to understand the k should be a constant quantity, then only towards numerator side you would be having the unit of radian per second has been raised to the power of 2, and similarly towards the denominator side. Yes, okay. So what we are going to do over here, let me briefly discuss about the few of the important component which we had over here. Just try to understand. May I know when you had been operating at omega is equals to 0, or you had been operating at very least value of operating frequency or the DC operating frequency, how much gain would be offered by this transfer function? Least operating frequency, omega is equals to 0. When the omega becomes 0, keep in mind, this would be vanished, and you would be left out with the k omega n square divided by omega n square. So in future, whenever I refer the k put together, you must have a greater clarity. What I am saying, the k had been the DC gain offered by the transfer function. So whenever I say the k is gonna be DC gain of the standard second order transfer function. Standard second order transfer function. Obviously, it's gonna be a unitless quantity. If we talk about its unit, it's gonna be the unitless quantity. Similarly, if we talk about the zeta, we have seen in terms of unit, it's gonna be a unitless quantity, and it's been said as what? Damping ratio. And the damping ratio is gonna be a very important factor which we are going to study into the great detail. So here is gonna be damping ratio. What does it mean by it? We'll see in future. But yes, the unit had been unitless. What had been the omega n over there? The omega n had been natural frequency of oscillation. Frequency of oscillation. The unit is gonna be a radian per second. Many of the times, the zeta and omega n had been referred together. Zeta had been a unitless quantity. Omega n would have the unit as radian per second. So zeta omega n would also have the unit as radian per second, and it's called damping coefficient. The unit is gonna be radian per second. I have seen many of the times used to have the doubt between the damping ratio or the damping coefficient. Many of the students used to have doubts, sir, in the given problem whether the problem had supplied the damping ratio or damping coefficient. You can search by its unit now. If it's been given that the zeta is being 0.1, 0.2, plus of 1, plus of 2, and if the unit had not been attached with that value, that means that had been a unitless quantity, and you have been talking about the damping ratio. But if in this problem zeta omega n had been supplied by stating it's been a damping coefficient, you can see the value had a certain unit or not. If the unit is being radian per second, by default you had been talking about, or the value which has been given along with this problem is being zeta times of omega n. So I can expect the important point where many of the students used to have doubt. The first doubt could be this point. What had been the k over there? Because nowadays the problem have started coming from this fashion, where the value of k deliberately they design somewhere 2, 3 or 4. In the same sequence, sometime I have seen the students should also have this problem, so whether the damping ratio is being given, whether the damping coefficient is being given. So I would say just focus over its unit. If it had been a unitless quantity, basically you have been dealing with the damping ratio, otherwise you have been dealing with the damping coefficient. Could you understood what I am saying? In the same sequence, we will see another important parameter which we would be encountering in future, and that had been omega of d. And that had been omega n root over of 1 minus of zeta square. My dear friend, the concept of damped frequency of oscillation, the omega d stands for damped frequency of oscillation. I repeat once again, damped frequency of oscillation. It would be the effective frequency of oscillation when the system had been behaving into the damped mode. That means it had been the keep oscillating, but still its magnitude is being keep suppressed. So it's been damped frequency of oscillation. And the unit is again gonna be radian per second. My dear friend, zeta had been a unitless quantity, then only 1 can be subtracted with the zeta square. My dear friend, we have seen earlier, probably in class 11, the addition and subtraction is possible only and only with the homogeneous units. What does that mean by the homogeneous units? 1 kilogram can be subtracted with a half kilogram. But 1 kilogram cannot be subtracted with the 1 kilometer, no, they had to be like unit. The zeta square had been the unitless quantity, 1 had been the unitless quantity, they can get subtracted together, they can take its square root, obviously it's going to be a unitless quantity getting multiplied with the omega n, again the result is going to be radian per second. So more or less you can say the omega d had been a type of oscillation which has been the oscillation in case of damped frequency of oscillation. And this concept is valid till the value 1 minus of zeta square remains a positive value. What I am saying, that means 1 minus of zeta square has to be a positive value. In that case, zeta has to be in between minus 1 to plus 1, because if the zeta goes beyond minus 1, let's take minus 1.1, in that case the zeta square would be greater than 1, 1 minus of greater than 1 would be a negative value, the square root of a negative value is going to create a iota. And similarly, if zeta goes beyond 1, let's take 1.1, 1.2, in that case what happens, 1 minus of 1.1 had been raised to the power of 2, again this value would be greater than 1, subtraction 1 with a value larger than 1 obviously again would make a iota. So what I am saying, the concept of omega d is gonna be a valid concept only and only if this factor is being positive, or I can say the zeta is being precisely 0 to 1, or I can say whenever the system remains in underdamped. Anyways, the underdamped word had been the new word for most of us. Anyways, we are going to discuss about those things also. So here it's gonna be underdamped, underdamped, underdamped. Yes, no? In the same sequence, let me go forward and let me focus over the important categories of the problem from where the question do come repeatedly. Most of the time, the system would be excited with the step input. That means, let's take the input had been R of t, reference input in time domain, and similarly its corresponding output, the control output in time domain is being C of t. In Laplace domain it's been written as capital R of s, and similarly this has been written as capital C of s. And here you had the transfer function which had been k omega n square divided by s square plus of 2 zeta omega ns plus of omega n square. May I know what would be the response? Obviously, if you have taken the Laplace of its input, and similarly if you know the transfer function, the output is simply going to be the multiplication in Laplace domain. And here I have taken the input had been a unit step input. Now many of the students would think, sir, why you have been taking the reference of unit step alone? Most of the time the question do come from the situation when the transfer function is being excited by the unit step, or maybe a step input with the step size of 2, 3, minus 2, minus 3. Why do they take the reference of a step input? Because this has been a bounded signal. My dear friend, if you have been exciting this system with the ramp or maybe parabolic signal, those signals had been an unbounded signal, and in that case even the output would also be unbounded in nature. So that is why, to avoid those situations, what we do, we used to focus over the input side, and the input has to be a bounded signal alone. So that is why most of the time the system would get excited with the unit step input, or for the in general I can say step input. Step input. So R of s, what's going to be the R of s? The R of s is simply going to be 1 upon s. 1 upon s is going to get multiplied with this, and that's going to be C of s, and the value which we have got it over here has been k omega n square divided by of s times of s square plus of 2 zeta omega ns plus of omega n square, and that had been the controlled output, or for the time being I can say the output, when the system is being excited with the unit step input. Okay, could you understand what I'm saying? From here, let me extract few of the important conclusions. So here comes the first important conclusion. May I know what would be the steady state value? What would be the steady state value of the response, obviously in time domain, small c of t? Again, we can use the final value theorem. What I am saying, many of the times you would come across a certain problem where you had to find the steady state value of the given system when it's been excited by the unit step input. So again, the same fundamental is going to get used, and that had been the limit s tends to 0, and here it goes s times of c of s, and that had been k omega n square divided by of s square 2 zeta omega ns plus of omega n square. The s and s had went out, they had been rubbed out, and once we start feeding the s is equals to 0, this goes off, we have been left out with the omega n square and omega n square, and the result which had been there in our hand, it's been k. So many of the times the k is also been said as steady state gain. What it's been? Steady state gain. So I repeat once again, I have seen once in a while they also refer k as the steady state gain. The k they refer as steady state gain. Why it's called the steady state gain? Because the input had been applied as 1, whereas at steady state the response had been settled at k. Response has been settled at k. So that is why the 1 had got the multiplication factor of k. So you can't we say the k as being a steady state gain? Yes sir. K can be said to be a steady state gain also. K can also be said to be a steady state gain also. But while using these important properties followed by the Laplace transformation, we also should ensure that this formula is being valid, or the final value theorem is being valid. For that, none of the pole of s square plus of 2 zeta omega ns plus of omega n square should go to the right hand side, should go into the right hand side, should not be over the j omega. For that, you had to ensure only and only one thing: the value of zeta, the value of zeta must be greater than 0. So what I am saying, when the final value theorem can be applied, already the final value theorem had been dealt into great detail probably 4 to 5 days back. There I discussed about the limitation of the final value theorem, what are the different Laplace functions where the final value theorem cannot be applied. We have discussed about those things in great detail. But as far as the second order system is being concerned, if you want to relate, neither of the pole should have gone towards right hand side or should have been to the j omega. You must have this situation, the zeta has to be greater than 0. Let me do one step more calculation. This value would always be positive. So what I am saying, this can't be negative, this would always be positive. This would always be positive. Now here the omega n would always be positive, s would be as it is. So what I am saying, if this factor 2 zeta omega n, if this factor is being positive, you need not to give any second thought. You can presume the zeta had been greater than 0 and the steady state theorem or the final value theorem is being valid. Final value theorem is being valid. Agreed? No? Final value theorem is being valid. So till this point, I don't find any of the student would have any sort of doubt now. Let me move forward. Let me focus over the characteristic equation of the second order system. Again, I am saying I am going to give a little bit idea about the second order system, and then straight away we would take few number of numericals based on the concept of second order system. So the characteristic equation is nothing but the denominator's polynomial is being compared with 0. Denominator's polynomial is being compared with 0. So may I know exactly where the poles would be located? Where exactly poles would be located? So you yourself would be able to understand. The poles or the roots of this quadratic equation could have been calculated with the help of Sridharacharya rule. How many number of roots you are going to have for this equation? As it's been the quadratic equation, the 2 number of roots you are going to have. Let's take the root had been located at S1 as well as S2. So we start with the Sridharacharya rule, minus times of b, that has been minus times of 2 zeta omega n plus minus, here it goes b square minus of 4ac. What had been b over there? The b had been 2 zeta omega n, that had been very same. Yes, no? B square, so here it becomes for zeta omega n. Write it down. Yes. So tell me what would be the exact locations of the pole. What would be the exact locations of the pole? So I think you would be able to calculate all of these steps. Straight away, let me write the locations of it. Let me write the locations of it. So here it goes. The location had been kept at minus zeta omega n plus minus j times of, either I can write the damped frequency of oscillation omega d, or we could have written this as omega n root over of 1 minus of zeta square. So nobody should have any doubts, sir, from where this process had come. Obviously you had to take the roots, or you had to calculate the roots of this quadratic equation with the help of Sridharacharya rule. You would be having the factor because of minus b, and you would be having the factor because of root over of b square minus of 4ac. From there we could get this result. Try to understand, probably this part is going to be a real part, and probably this part is going to be the imaginary part, provided there should not be any introduction of the negative sign within the square root. If the zeta goes beyond 1, what I am saying, if the zeta goes beyond 1, in that case what happens, the negative sign get introduced within the square root, that would again create a iota and iota would get multiplied, and this would also be real and this would also be real. So what I am saying, this has been the imaginary part of the root, provided the worth of zeta had been in between minus 1 to plus 1, because in between minus 1 to plus 1, zeta square is going to be lesser than 1, and in that case it's going to be a real part. Put together, it's going to be a consolidated imaginary part. Could you understand what I am saying? So what we have been doing over here, we had been discussing, or we had been focusing over one of the important equation which is being followed by this. May I know what it is? This has been the real part, this has been the imaginary part. So what we have been doing over here, the real part it's been taken as x square, imaginary part had been taken as y, and it has been raised to the power of 2. Once you do so, the square of this is simply going to be minus, has been raised to the power of 2, that would become plus zeta square of omega n square, and here it becomes omega n square getting multiplied with 1 minus of zeta square, Once you'll open it, you'll get to know the omega n square minus of omega n square into zeta square. Omega n square into zeta square is going to get knocked off. So one thing had been quite sure. The x square plus of y square had been equals to of omega n square irrespective of the value of zeta. Is it clear to all of us? Could you really understood what exactly I wanted to communicate through this outcome? Irrespective of the value of zeta, the x square, or I can say the real part square plus of imaginary part square had been equals to of omega n square. That means for the range zeta is belonging in between minus 1 to plus 1, for the different values of zeta, definitely locations of the closed loop poles are going to change, but still they would be located over an origin which has been centered at origin and had the radius is equals to of omega n. Could you understand what I am saying? So one of the very important conclusion which we can deduce out of it is being, if zeta is being 0 to 1, this remains a complex part. Your poles would be located on a circle whose radius is being omega of n, and it's been centered at origin. Could you really understood what exactly I wanted to communicate over here? So let me do one thing. Let me bring this complete scenario towards right hand side, and let me draw a circle over here. So here goes a circle, and let's take this has been the real axis. May I know what would be the real axis and what would be the imaginary axis? My dear friend, this has been the S plane, no? Still, whatever the calculation had been taken place, that had been taken place over the S plane. So by default, it's gonna be the real part of the S, that's going to be the sigma axis, and that's going to be the j omega axis. And here the value of sigma as well as omega had been 0, or you can say this has been the point S is equals to 0. This has been the point S is equals to 0. So we have fabricated a circle. We have fabricated a circle whose center had been kept at origin, and at the same time it had the radius is equals to of omega n. So if we'll talk about the intersection of the positive real axis towards right hand side, it's simply going to be at omega n comma of 0. Omega n comma of 0. If you talk about the intersection with the positive imaginary axis or positive y axis, and simply going to be 0 of omega n. 0 of omega n. This point is simply going to be minus of omega n comma 0, and here it's going to be 0 of minus of omega n, or you can say this has been 0 plus of j omega n in complex form. This could have written as j omega n, this could have been written as omega n, this could have been written as minus of j omega n, this could have been written as minus of omega n, minus of omega n, minus of omega n. And if we'll talk about the radius of this circle, it's been fixed to omega of n, omega of n. Yes, no? Could you understood what exactly I wanted to communicate over here? So let me start with the different values of zeta, and we'll try to find where the closed loop poles are exactly located. Let me start with the zeta is equals to 0. When the zeta is being fed as 0, obviously the real part vanishes, and here it had been omega n square into of 1, and obviously it had been a case where the poles is being located at j omega plus n, and similarly minus j omega n. So at omega zeta is equals to 0, zeta is equals to 0. Zeta is equals to 0. The two closed loop poles, obviously they would be symmetrically located taking the reference of x-axis, and they had been placed at plus j omega n as well as minus j omega n. Plus j omega n as well as minus j omega n. May I know, as the value of zeta would be increased, let's take it's been 0.1, 2, 3, 4, what would be the changes in their location? My dear friend, if the value of zeta had been in between minus 1 to plus of 1, no, that is for sure those poles are going to be lying over a circle which has been centered around the origin and had the radius is equals to omega n. That means those roots are going to come over the circumference of the circle alone. But how they would be displaced? As the value of zeta is increasing, no, you yourself would be able to understand this factor is going to be more and more stronger, and negative sign indicates the roots would start shifting towards the negative real part, If you'll move towards left hand side, what's been happening? Obviously the negative real part is becoming more and more negative. That's the first thing is been happening. And if we'll talk about the imaginary part, no, as the sigma or zeta is being more and more strengthened, no, this factor is going to get decayed, and as this factor is decaying, no, the imaginary part is going to decay, and as the imaginary part is going to decay, definitely now the poles would start coming nearer in vertical sense. So in horizontal sense, it had start shifting towards left hand side, and in vertical sense, they started coming down. So put together how their situation had been. So they would start changing their locations. Let's take, this has been the first location, this has been the second location, this has been the third location, this has been the fourth location, and this has been the situation where the value of zeta had been keep increasing. Here zeta was 0, and precisely when the zeta would become 1, no, and precisely when the zeta becomes 1, obviously 1 minus of 1 square would be vanished. It would be only and only pure real in nature. That means both of the poles had been repeatedly found at minus zeta omega n, where the value of zeta had been 1. So precisely they would be repeated at minus of omega n alone. So what I am saying, at zeta is equals to 0, both of the closed loop poles were kept over the j omega axis, and as the value of zeta had been increasing, what had been happening, they had been keep shifting towards the left hand side, but still they had been circling over the circle alone, and similarly at the same time their imaginary part had been keep reducing. Yes, it had been moving towards left hand side. Could you understand what I am saying? So from here at least one thing must be there in your mind. Whenever the zeta is in between 0 to 1, the nature of the roots are gonna be complex conjugate in nature with negative real part, and as the value of zeta goes exactly 1, the both of the roots would be repeated as well as negative real part they are going to have. Could you understand what I am saying? May I know what would happen if the zeta would go beyond 1? If the zeta would go beyond 1, no, in that case what had been happening, my dear friend, this factor would be more higher than this value. So obviously root over of 1 minus of a value which is higher than 1 would create a iota, and iota is going to get multiplied, and now this is also making a real part. The one real part is going to get added as well as subtracted with another real part. What would happen? It would create a real part, and they are going to be the two distinct real part. So what had been happening over there? As the value of zeta would go beyond 1, no, one closed loop pole would try to go towards this side, the another pole would go to this side, and they would be pure real in nature. Yes. So let me do one thing. Let me conclude what are the different outcomes which we have deduced, which we have extracted so far, and we would try to analyze them together, and we would take few number of numericals also. We would take the few number of numericals also. For that, let me draw a table over here. Okay. Let me take the different values of zeta, and we would try to categorize the system would fall under which category and how would be its output response. Obviously, we have taken the system had been excited with a unit step input. Yes. Okay. Then let me start with first, and here it goes serial number. Let me take that had been 1, that had been 2, that had been 3, that had been 4, and we can take remaining one. And let me talk about the range of zeta. At very beginning, the value of zeta is being taken as 0. Then the value of zeta is being taken as in between 0 to 1. Then the value of zeta had been taken as precisely 1. Then the value of zeta had been taken as greater than 1. And even if you want, we can go towards the negative value of zeta, but the negative value of zeta has not been analyzed much, because whenever the zeta becomes negative, system becomes an unstable system, because the pole goes towards the right hand side of the S-plane. But still, if you want, we can do the analysis of that also. We can take the fifth one, where the zeta was in between -1 to 0. Zeta was precisely equals to of -1, and the zeta was lesser than -1. If you want, we can take the total 7 number of cases. Yes. Tell me, zeta is equals to 0. Which kind of the system it's being called? The type of the system it's being. Type of the system. Which kind of the system it would be called of? Tell me, which kind of the system it would be called of? At zeta is equals to 0, if you want to see, you yourself would be able to understand, my dear friend, when you would feed the zeta is equals to 0, the response has been k omega n square divided by of s square plus of omega n square. If you will take its Laplace inverse, you will find you would be having the two factors. First factor would have s towards denominator side, the second factor would have s square plus of omega n square towards the denominator side. 1 upon s would make it a DC component, s square plus of omega n square is going to make a sinusoidal component. So what I am saying, whenever you feed zeta is equals to 0, you will find you have landed up to the situation that the system, if it is getting excited by the unit step input, the output would be undamped in nature. What does that mean by the damping? Damping is being the internal pravitti of the system which forces to reduce the oscillation within the system. So can I say we have an internal phenomena of the system which had been suppressing the oscillation of the system? Not at all. So keep in mind, whenever the zeta is being kept as 0, I say the type of system is being the un means no. Damping, no sir, there had not been any damping at all. So what I am saying, it's an undamped system. Undamped system. Could you understand what I am saying? Undamped system. Similarly, if we'll talk about the zeta is being 0 to 1, may you know what would be the nature out of it? What would be the nature out of it? You will see this factor would be s square plus of 2 zeta omega ns plus of omega n square. Zeta had been in between 0 to 1. This factor do come into the picture because of, obviously again two factors we are going to have. The first factor is going to be a divided by of s. The second factor is going to be s square plus of 2 zeta omega ns plus of s square omega n square. But here what had been happening, did you understand what exactly it is? This factor do come because of the factor called e to the power of minus t sin t, maybe e to the power of minus 2t sin t, e to the power of minus 3t sin t. What does that mean of it? Because of this there would be the damping. Because of this, there would be the oscillation. I would repeat once again, this has not been the complete course where I would exactly discuss from where this outcome had come. But what I am saying, when the zeta had been in between 0 to 1, no, if you will take its Laplace inverse, the two factors is going to come. The first factor is going to be the DC component. That would remain its magnitude fixed from t is equals to 0 onwards. But the second factor is going to be having the two component. The first component is going to be the oscillation component, and the second component is going to force to reduce that oscillation over the period of time. Could you understand what I am saying? And if it had been happening, may I know which type of system it would be called? The system had been under the concept of damping. I call it underdamped. What does that mean by the underdamped? The factor of e to the power of minus t sin t would be applicable over there. And here there would be the oscillation, but the oscillation would be keep damped or would be keep decreasing as the time passes. So here is going to be, which type of system it's been? It's going to be underdamped system. It's been underdamped system. Yes, it's been underdamped system. And now if you keep zeta is equals to 1, may I know how the nature of the system would be? My dear friend, if zeta is being kept as 1, no, so this could have been written as s plus of omega n has been raised to the power of 2. Yes sir, agreeing. I repeat, how the system it would be? It would be s square plus of 2 times of omega n plus of omega n square. That could have been written as s plus of omega n, which has been raised to the power of 2. Could you understand what I am saying? And because of that, it's gonna be the pure exponent in nature. So what I am saying, at zeta is equals to 1, the system is gonna be critically damped. What does that mean by the critically damped? It had been the critical value of zeta. From there onwards, there would not be any oscillation. What I am saying, it had the output in a form of oscillation, but it had not been damped. That means it was keep oscillating with a constant magnitude as well as frequency. Here the oscillation was there, but still the oscillation or the magnitude of the oscillation was keep decaying as the time was passes. But here it had been the critical most value of zeta. From here onwards the response would not be oscillatory at all. It would be pure exponent. It would be pure exponent. Agreed what I am saying? So here it goes overtimed. Overtimed. I am not going to discuss much about it. When I would be taking few number of previous year questions, I would be discussing about the range of zeta over here. But one thing is being quite sure, if the value of zeta goes towards a negative value, the system becomes an unstable system. System becomes an unstable system. So I am not talking much about it. I am not talking much about it. So the student who had a little bit idea about the output behavior, may I know how would be the output behavior over here? Output behavior. Output behavior. The nature of the closed loop poles. Nature of the output poles. At zeta is equals to 0, we have already seen, at zeta is equals to 0, both of the complex conjugate poles were kept over the j omega axis. So which kind of the poles they had been? So it's gonna be pure imaginary, obviously in a form of complex conjugate. Pure imaginary in a form of complex conjugate. In a form of complex conjugate. Could you understand what I am saying? Now let's take the zeta is being 0 to 1. One thing has been quite sure, if the zeta has been precisely 0, both of the poles were located over the j omega axis. When the zeta has been brought to 1, both of the poles were located precisely at minus of omega n. But when the zeta had been in between 0 to 1, no, the poles were located in between this range. Or I can say the nature of the pole had been in a form of complex conjugate, but its real part had been negative in nature. If you locate the exact location of the poles which have been situated at 2 and 2 dash, you will get to know, sir, they had been in the form of complex conjugate, but its real part had been negative. So what I am saying, one of the important conclusion we could have retrieved out of it, and that had been the nature of the poles are gonna be what? Is gonna be complex conjugate, but here the real part is gonna be negative in nature. The negative real part it's going to have. Negative real part it's going to have. Yes? In the same sequence, if you'll go ahead at zeta is equals to 1, you yourself would be able to understand it had been pure real. It had been pure real, I repeat, it had been pure real. And that too real part had been negative in nature and they had been repeated. So what had been the outcome over here? It's been pure real, negative and repetitive. Pure real, negative and repetitive. Yes. May I know what would be the case over the zeta greater than 1? Obviously, both would be pure real. They would again be negative in nature, but they would be distinct. If we talk about the behavior of the output at zeta is equals to 0, it's gonna be the sustained oscillatory, or the oscillation with the constant magnitude and frequency. Similarly, at zeta is been in between 0 to 1, it's been a damped oscillation, or I can say oscillation with reducing or decreasing magnitude. Imaginary. Pure imaginary and complex conjugate I am saying. No, it's not been repeated. At zeta is equals to plus of 1. That used to be pure exponent. That means the concept of oscillation vanishes from here onwards. Pure exponent, and here it goes delayed exponent. exponent. It's been delayed exponent. Yes. So let me draw the different situations. It won't take much time. Let me draw the different situations. Different situations. It's gonna be t versus y of t. It's gonna be t versus y of t. So may I know what does that mean by the damped oscillation? That means it had been oscillating with the decreasing magnitude. And obviously it would go to the steady state value. And may I know what would be the worth of its steady state? That we can easily calculate with the help of final value theorem. May I know exactly where it gets stuck? It gets stuck at K. It gets stuck at K, which we have already seen earlier. So you can say it had been its steady state value. Agreed? I am not going into the detailed analysis, at least for the today's class. Let me take few number of questions, and with the help of those questions I would try to categorize which kind of the system it had been. What I am saying, I am not going to go into the much graphical study of either of them. Let me briefly discuss about the different transfer function, and with the help of those transfer function we are going to ask few number of questions. So let me design few number of questions in front of you. So here goes the first question. The question had been 4 divided by of s square plus of 2s plus of 4. This has been the system excited with unit step input. Let me ask few number of questions. So what are the different questions we can frame out of it? It's been the first question which we are going to ask, which type of system it had been? Underdamped, overdamped, critically damped, unstable system, which kind of the system it had been? Type of system it had been. May I know how exactly you would be able to understand the type of system it's been? Only focus over the zeta. The different values of the zeta, the different range of the zeta belongs to different kinds of the systems. Either it could be undamped, overdamped, critically damped, unstable system. So obviously you had to focus over the zeta first. Focus over the zeta first. Once you are done with that, tell me what would be the steady state response of the output. Steady state response, obviously when it's been excited with the unit step u of t. Steady state response. Similarly, you also calculate what would be its initial response, or I can say the response y of t at t is equals to 0. Initial response. What's gonna be its initial response? And I would also like to know what had been the nature of the poles. Pure real, repetitive, pure real, distinct, complex conjugate with a negative real part. There are several kinds of the output which we can deduce out of it. It's been nature of the poles. Tell me. Start giving the answer. Which kind of the system it had been? Whenever you had to categorize the type of the system, focus over the zeta. And whenever you wants to calculate the value of zeta, always focus the polynomial towards the denominator side, because towards the numerator side you may also have the multiplier factor of k, which is also been called as the DC gain, or is been also called as a steady state gain. So many other times I have seen the student used to have one doubt. What they would do, they would just compare the numerator with the omega n of square. They would get the value of omega n, and from that omega n they used to calculate the zeta. So what I am saying, whether they had been same or whether they had been different, always take the reference of the constant towards the denominator polynomial. Denominator polynomial. So 4 had been at location of omega n square. Omega n square had been 4, so obviously the value of omega n is supposed to be 2. And this has been in the place of 2 times of zeta omega n. 2 times of zeta omega n. So what I am saying, 2 times of zeta omega n had been to itself, where the value of omega n has been known to me, and that had been 4. So here it becomes not 4 actually, it's been 2 now. So here it becomes 2 to the 4. So the value of zeta had been 0.5, which had been in between 0 to 1. The type of the system which we are going to have is going to be underdamped system. It's going to be underdamped system. May I know what would be the steady state response of it? When the excited input had been u of t, when the u of t becomes 1 upon s in Laplace domain, gets multiplied with it, you had to take limit s tends to 0, s. End of the day, the result is going to be this goes off, and you had been left out with the 4 divided by 4, and that's nothing but 1. So the output would be damped oscillatory, it would be decreasing, and now it would get settled at 1. Yes, tell me what would be the initial response? My dear friend, whenever we have been talking about the standard first order system, when it's been excited with the unit step, always the initial value would be 0. How? You would apply the initial value theorem that used to be limit s tends to infinity s times of the complete transfer function. As you can say, when you will take limit s tends to infinity s times of, the degree of the numerator is going to be 1. The highest power of s at numerator is going to be 1, and highest power of s towards denominator is being 2. What does that mean of it? That means when the s would be tends towards infinity from the concept of limit, this value would always and always be 0. Nature of the poles. So obviously, if the zeta had been in between 0 to 1, the nature of the poles had been complex conjugate with negative real part. Negative real part. Okay then. So this is all for the today's class. So we had a little bit idea about the important conclusion which we have retrieved. Agree? We were discussing about important terminologies as well as the important formulas which are getting involved in the second order system. We also talk about the constant omega n circle. Here we talked about a complete table at which we have categorized the complete output into 4 different characters in terms of zeta, type of system, output behavior, nature of the poles, and end of the day we have tried to take a problem. So I would request to each one of you, the student who have already had a little bit idea about the control system, what they can do, they can go through the second order system problems as well as theory once again. and we would straight away take few number of numericals from tomorrow onwards, and probably 2 more sessions we are going to conduct over the second order system, because the second order system had been a very important topic, at least for the control system, at least for the control system. Agreed now what I am saying? So if you guys are having any sort of doubt, you can ask, otherwise we had to end the today's session. Okay then, this is all for the today's class. We would meet tomorrow precisely at the same time, that used to be at 3 p.m. Till then, bye bye, take care.